This lesson is 11.1 Lines and Angles. Our goal today in this lesson is to know precise definitions involving parallel lines. We're going to learn about all the different names of angle relationships between angle pairs here. Okay, to start, we need to define what parallel lines are. They are two lines. Parallel lines are coplanar lines that do not intersect. So here's a picture. We've got line AB and line CD. They are parallel because they do not cross each other, and they are also in the same plane. Why we have to say that they're in the same plane is because of this. Skew lines are non-coplanar lines. They do not intersect, just like parallel lines, but aren't parallel. So if you look at this picture, line DE and line GF, those are definitely not parallel, but they also don't intersect because they're in different planes. Okay, a transversal is a specific type of line. It's a line that intersects two or more coplanar lines. So if you have two or more lines and a line cuts through it, that line that cuts the other lines is called the transversal. So in this picture, line T is a transversal line because it cuts through line M and line N. Okay, when we've got transversals, the region between the two lines cut by the transversal is called the interior region. And the remaining regions of the plane are the exterior regions. So this probably doesn't make sense until you have a picture. So we've got line T cutting through line M and N. Notice that inside line M and N is called the interior region. Therefore, the outside stuff is called the exterior region. Now we're going to talk about some angle pairs that are formed by transversals. We have a bunch of different vocab words that are going to be thrown at you here, and we're going to start with the first one, corresponding angles. Corresponding angles are two angles that are positioned in the same position, just on different levels. Same location, just different levels. So if you look at angle 1, angle 2, angle 3, and angle 4, angle 1 is the top left angle, and angle 5 is the top left angle down below, 5, 6, 7, 8. So angle 1 and angle 5. See how they are in the same positioning, just different levels? Those are called corresponding angles. So if you look at the figure again, there's not just one set of corresponding angles, there are more. Angle 3 would be corresponding with angle 7. So if you look right here, angle 3 would be corresponding to angle 7. Let me use different colors here. Angle 2 would be corresponding with angle 6. And then angle 4 would be corresponding to angle 8. These are corresponding angles. Moving on to the next one, we've got alternate interior angles. We just learned that the interior region is inside the two lines. So if we have this figure again, we're only talking about the interior region here. So since these are alternate interior angles, I know it's going to be one of these. Basically, it has to be on the inside of parallel lines or just lines in general. They don't have to be parallel. So if we look, we've got angle 3 and angle 6 are alternate interior angles. They are inside the parallel lines, but they are also on opposite sides of the transversal. So that's where you get the word alternate from. Interior because they're inside the lines, alternate because they're on opposite sides of the line. So angle 3 and angle 6 are alternate interior. And then if you notice, there's another set of alternate interior angles. Angle 4 and angle 5 would also be considered alternate interior angles. So angle 4 and angle 5 would be alternate interior. Okay, next vocab word, next angle pair. Alternate exterior angles. So if you remember, exterior angles were on the outside. So they have to be either out here or out here. So alternate means on opposite sides of the transversal. Exterior means on the outside of your two lines that are together, cut by the transversal. So that would mean angle 1 and angle 8 have to be alternate exterior because they're on opposite sides of the transversal. And they're also on the exterior of the two lines. And then also, if we look closer, angle 2 and angle 7 would be alternate exterior angles. Angle 1 and angle 8, angle 2 and angle 7. Next one, same side interior angles. So I see the word interior, so that means that I'm going to be talking about this region. So I'm going to be talking about 3 and 4, 5 and 6, or 3 and 5, 4 and 6, some kind of combination on the inside of the two lines. So it says same side, and the reason why we say same side is because the two angles have to be on the same side as the transversal. So angle 3 and angle 5, these will be same side interior angles. And you'll notice that there is another set of same side interior angles. 4 and 6 are same side interior angles. So again, 3 and 5, 4 and 6. Okay, and lastly, same side exterior angles. So same side of the transversal, exterior area, exterior region of your figure. So we're talking about out here and out here. So that's exterior region. And we're looking at angles that are on the same side of the transversal. So let's see. 2 and 8 are on the same side of the transversal and on the exterior, in the exterior region. And then also angle 1 and angle 7. So angle 1 and angle 7 are same side exterior angles, and angle 2 and angle 8 are same side exterior angles.